Imagine your favorite AI assistant abruptly rewriting your core authentication module because it got trapped in an endless logic loop while you were just grabbing a coffee.
Yeah, that's pretty much a nightmare scenario for any developer.
Right. Or picture your machine sounding like a jet engine at 2 in the morning because a background process decided to silently hoard gigabytes of memory.
Which, unfortunately, actually happened to quite a few people recently.
Exactly. Well, welcome to today's deep dive. We are thrilled you're joining us.
Absolutely.
Our mission today is to help you cut through the absolute noise of an insanely aggressive week in developer tool updates.
And it really was an aggressive week. Between April 4th and April 10th, 2026, we saw so much movement.
So much movement. We are filtering out the routine bug fixes to uncover the structural changes that will actually impact your daily workflow.
Because there's a lot of signal buried in that noise.
Yeah, we've got a massive changelog in front of us covering 13 different releases across 2 major tools in just 7 days.
We're looking specifically at Claude Code, GSD, Superpowers, and the marketplace.
Okay, let's unpack this. 9 versions of Claude Code in 7 days. They jumped from version 2.1.92 to 2.1.101 in a single week.
It's a huge jump.
That's not a software update schedule. That's a marathon. I mean, is this pace even sustainable, or are we just watching pure chaos unfold in real time?
Well, from the outside, it certainly looks like Canic-driven development, I'll give you that.
It really does.
But, tracking the commit history reveals a very deliberate underlying pattern.
Okay, what kind of pattern?
The cycle was basically fix a critical regression, ship a cluster of quality of life updates, immediately fix the new regression that caused,
Yeah.
and then repeat.
So break things, fix them, break them again.
Essentially, yeah.
Yeah.
But if we connect this to the bigger picture, this week was fundamentally about 2 distinct mandates.
Right.
In the short term, the mandate was stopping silent failures, those, invisible cascading bugs that just destroy developer trust.
Oh, absolutely.
And in the long term, the mandate was building persistent cross-session memory.
Stopping silent failures. I love that framing. Because honestly, there is nothing more infuriating than a tool that fails and doesn't even have the courtesy to log an error code.
It's the worst.
Looking at the sheer volume of these Claude Code updates, the engineering focus was clearly heavily weighted toward fixing those invisible leaks behind the scenes.
Yeah, and the stale worktree fix in version 2.1.1001 is a perfect example of addressing an invisible leak.
Okay, break that down for us.
Let's say you're running an isolated agent in worktree using the command clog-do-you-name, and then, say, your terminal crashes. Or maybe you instinctively hit Control-C a bit too quickly, so that session terminates abruptly.
The directory just hangs out there, right?
Exactly.
It's dead, but the file system still thinks it's occupied by an active process.
Right, so the next time you attempt to run that exact command, the system just throws an e-existed error.
Oh, wow.
It simply fails
Right.
because it cannot handle the ghost of the previous session.
So you'd have to completely context switch, manually hunt down the stale directory, delete it, and start over.
Yeah, which is incredibly tedious.
Yeah.
But version 2.1.101 finally introduces an automatic cleanup protocol.
Nice.
The system now actually detects the stale state of the directory and purges it before attempting to create the new worktree.
Which saves developers from that maddening micro-interruption.
Totally.
But dealing with phantom directories was honestly just the tip of the iceberg. There was a much more severe problem happening right under our noses with memory management.
Oh, the virtual scroller memory leak.
Yeah.
This is particularly devastating during those deep, hours-long GSD phase execution sessions.
Because a virtual scroller is supposed to only render the items currently visible on your screen, right?
Exactly. It's supposed to be recycling the DOM elements as you scroll to keep memory usage flat.
Instead, it was doing the exact opposite.
Yeah, it was.
Every prompt, every response, every massive block of refactored code generated over a 4-hour session was retaining a historical message copy in the background.
It was keeping a live reference to literally everything.
It was silently eating hundreds of megabytes, sometimes gigabytes, of RAM.
And the longer you trusted the AI to work, the more unstable your entire development environment became.
Which defeats the whole purpose.
Right. Thankfully, version 2.1.101 finally plugs that leak by ensuring those historical references are actually garbage collected.
So the system can finally breathe again?
Exactly.
But, there was another silent failure in this changelog, and this one honestly blew my mind when I realized the implications.
The sub-agent file permission bug.
Yes! Think about it like this. It's like hiring a brilliant assistant. giving them their own private office, but locking their own filing cabinet so they can't actually do any work.
That is basically exactly what was happening.
That is effectively what Claude Code was doing to its subagents.
That analogy perfectly captures the structural flaw, because subagents are explicitly designed to run in isolated work trees for sandboxing purposes.
You want them contained.
Right, you want them contained. However, the permission system was deeply flawed. When the subagent attempted to read or edit a file, the permission check was routing back to the parent session's working directory.
Completely bypassing the subagent's own isolated route.
Yeah.
So the subagent was literally being denied access to the very files it was created to modify.
Exactly. And because it's a subagent running in the background, it couldn't surface a clear permission error to the developer.
Right, so the developer would just see a task sitting in the queue, failing to execute, and assume the model itself was hallucinating or just incompetent.
Exactly. Fixing this in the latest update is a massive restoration of trust.
Absolutely.
True agent isolation actually works now. You can delegate long-running background tasks in Claude Code, knowing they aren't going to silently fail due to an inverted permission check.
Okay, so the environment is actually stable. It's not hoarding RAM. The agents can open their own files, and the stale directories clean themselves up.
It's a solid baseline now.
Right. With that foundation finally solid, the focus clearly shifted to how the tool behaves for you, the listener. We moved from bug fixes to some very intentional shifts in operational philosophy.
Yeah, this is where it gets strategic.
Like in version 2.1.94, they raised the default effort level to high, specifically for API key and enterprise users.
Which represents a major philosophical shift in AI tooling. By defaulting to high effort, Claude is explicitly instructed to spend more time thinking through edge cases.
Okay.
It's weighing architectural trade-offs and prioritizing absolute correctness over immediate output speed.
Wait, I have to push back on this.
Okay, go for it.
I understand the value of correctness, but for a solo developer or a small startup running on a strict API budget, a default high effort feels like a forced upgrade.
I see where you're coming from.
Aren't API users just going to burn through their token credits significantly faster? Like, if I just need a quick scaffolding for a basic utility function, I don't need the AI pondering the deep philosophical implications of my variable names while the meter is running.
It is a very real trade-off between speed, cost, and quality. And your concern about token burn is totally valid.
Right.
But what's fascinating here is the underlying math the developers are betting on.
What do you mean?
It's akin to shifting from a just-in-time compiler to an ahead-of-time compiler. You pay a slightly higher computational tax upfront.
Okay, I follow.
But a fast, cheap answer that contains a subtle logic error, say, a weird race condition in that basic utility function, is infinitely more expensive to debug 3 weeks later.
Oh, that's true.
It's much cheaper than paying a few extra tokens today to get it structurally sound the first time.
So you are basically trading API credits for human debugging hours.
Exactly.
I suppose when you frame it that way, the return on investment makes sense, provided you actually have the budget. Are developers just locked into this higher tier now?
No, you can still override it if you need the speed for simple tasks.
Oh, okay.
But making high the default indicates a belief that AI is moving from a quick autocomplete tool to an actual architectural partner.
That makes sense.
And speaking of efficiency and automated workflows, the changes to rate limit retry messages in version 2.1.1.01 are a game changer for continuous integration environments.
I saw that. Previously, hitting a rate limit was essentially a black box.
Completely.
You'd get a generic rate limit exceeded error, and your pipeline would just fail. You were left staring at the terminal wondering, do I pause the script for 10 seconds? Do I wait an hour?
Developers were literally writing arbitrary sleep commands into their batch scripts and just crossing their fingers.
Just guessing.
Yeah. But now, the retry messages provide structured, exact data.
Right.
They expose whether you hit the request per minute limit, the tokens per minute limit, or your total daily quota.
And crucially, they provide the exact reset timestamp and identify the specific model that triggered the block.
Exactly.
From a structural perspective, that completely changes how you build automated pipelines. You don't have to write arbitrary wait times anymore.
No, you really don't.
Your script can just read the JSON response headers, parse the exact Unix timestamp for the reset, and put the thread to sleep for exactly the right number of milliseconds.
It replaces guesswork with programmatic precision.
It's beautiful.
They also removed another major friction point for back-end automation, the hard-coded 5-minute request timeout.
Oh, man. Previously, if you asked Claude Code to process a massive multi-file refactor and the backend operation took longer than 5 minutes, the client would just ruthlessly abort the connection.
It's brutal.
Imagine hitting 4 minutes and 59 seconds of deep processing, only to have the tool panic and drop the connection.
It essentially put a hard ceiling on the complexity of tasks you could delegate.
But that ceiling is now gone.
Yes. And to support these longer unbounded operations, version 2.1.98 introduces a new monitor tool.
Which streams events directly from those background scripts. So while the AI is taking 20 minutes to process a heavy refactor, you finally have real observability into what's happening behind the scenes, rather than just staring at a blinking cursor hoping it hasn't crashed.
Exactly the point. Claude Code matured significantly this week. It's less fragile, it communicates its limitations clearly, and it's actually configured to take the necessary time to do complex jobs correctly.
Okay, so if Claude Code spent the week fixing the immediate session, it leaves a much larger structural problem, untouched cross-session amnesia.
Right.
GSD tackled this aggressively, jumping from version 1.32.0 to 1.34.2 over essentially a single weekend.
The pace was wild. And the substance of the GSD updates is overwhelmingly concentrated in version 1.34.0.
Okay.
The standout feature, the one that will fundamentally alter how you interact with your codebase over the next year, is the global learning store.
We need to dive deep into this because this feels like a massive paradigm shift.
It really is.
Up until now, GSD would learn the quirks of your codebase during an active session, storing that context in the ephemeral .planning directory. But the moment you cleared your cache or moved to a new environment, that intelligence was just wiped.
Completely gone.
It's like having a junior developer where every single morning you have to say, "Hi, here's how our database is structured. Please remember we don't use underscores and variable names, and here is how we handle authentication state."
Reestablishing that context window every single session is incredibly inefficient.
It's exhausting.
With the global learning store, those structural insights are now persistent. They are stored outside of the ephemeral planning directory.
Okay, so how does that actually work?
When GSD completes a phase, any new architectural insights or rules it discovered are automatically copied to this global store.
How does that actually manifest in a daily workflow, though?
Well, the next time you open a session, the planner automatically pulls those persistent learnings as base context.
Oh, that's incredible.
And you can manage this intelligence layer using new CLI commands like GSD tools learnings list or add or tag.
So you have full control over it.
Exactly. But it goes deeper than just a list of rules. GSD now maintains a queryable code-based intelligence layer.
The new planning Gintel directory.
Yes. It builds and maintains a persistent, structured JSON map of your codebase's relationships.
Wow.
It understands how your authentication module connects to your database schema, and you can query that structure directly using GSD tools Intel commands.
So it's essentially building a living, searchable graph database of how your specific architecture actually functions.
That's exactly what it's doing.
You are transitioning from using reactive software like a tool that only responds to your immediate prompt to building a compounding asset.
Precisely.
The longer you use GSD, the smarter it gets about your unwritten rules and legacy quirks.
It adapts entirely to your environment. And speaking of adaptation, version 1.34.0 also introduces an adaptive model preset, which addresses your earlier concern about API token costs perfectly.
Right. From what I understand, instead of locking you into a single model for the entire workflow, the adaptive model preset assigns different AI tiers based on the specific role required at that moment.
Yet dynamically.
So it uses a highly capable, more expensive model for complex architectural planning and deep code review.
Right.
But when it transitions to simple execution or basic linting verification, it dynamically swaps to a faster, cheaper model.
It optimizes the entire pipeline. It maximizes the high-effort computational power where structural decisions are being made.
Which is where you want it.
Exactly. And rigorously saves time and money during road execution.
Right.
You don't have to manually toggle your .env variables between phases anymore.
That level of autonomy is incredible. But giving a persistent AI the ability to dynamically switch models and execute complex plans based on its own cross-session memory creates a terrifying new vulnerability.
It definitely opens up some risks.
Like if it hallucinates a better way to route your API while you're not looking, it's doing so with a lot more authority now.
Which is why pushing toward higher autonomy necessitates drastically stricter guardrails.
Absolutely.
You cannot build a compounding intelligence engine without preventing it from corrupting the very system state it's trying to improve.
Right, and looking at the changelog, the engineering team clearly recognized that vulnerability.
Oh, they definitely did.
Let's look at the cross-platform planning lock fix for Windows that landed in version 1.33.0. On the surface, it sounds like a dry synchronization patch.
Yeah, it does sound a bit dry.
But my understanding is this was causing catastrophic state corruption for Windows users.
It was a severe architectural flaw. When GSD transitions between complex phases, it must lock the planning state, so two asynchronous processes don't attempt to edit the plan simultaneously.
Makes sense.
Previously, the tool was relying on a clunky shell sleep command to handle this waiting period.
Essentially telling the system, just pause for a random number of milliseconds and hope the other process finishes saving.
Right, which relies entirely on the operating system's scheduler, which is notoriously imprecise.
And on Windows environments, that imprecision was fatal.
Very much so.
Two processes would inevitably collide, writing to the planning directory at the exact same moment, corrupting the entire state and forcing you to start the phase over.
It was a mess. But the fix replaces that crude sleep timer with atomics.wait.
Oh, interesting. For those working outside of Node.js threading primitives, atomics.wait is fundamentally different because it halts the thread at the system level, right?
Yes, exactly.
It puts the thread to sleep, consuming 0 CPU cycles until it is explicitly woken up by the lock releasing rather than just guessing with the timer.
The technical elegance of atomics.wait is its absolute precision. It interacts directly with a Node.js event loop to guarantee synchronization.
That's a huge upgrade.
It entirely eliminates the Windows lock failures. The state corruption issue is completely resolved.
Here's where it gets really interesting to me, though.
Wow.
We are building these highly advanced, context-aware AI planners, and yet in version 1.34.0, they had to introduce stall detection and hard stop safety gates.
Yeah, the irony is thick.
We are literally building automated babysitters to stop the AI from talking to itself.
It's true. The plan phase revision loop now has active, aggressive monitoring.
What is it looking for, specifically?
It specifically watches for 3 failure states, 0 progress being made across multiple turns, the AI making repeated identical tool calls that result in errors, or the AI getting trapped in contradictory instruction loops.
A contradictory loop is fascinating.
They're hilarious, honestly.
Like, it writes a piece of code, reads a linter error, tries to fix it by reverting to the old code, which then triggers a design system error.
Yep.
The AI decides to fix the design system error by reverting back again, and it just spins forever, burning thousands of tokens a minute while you're away from the keyboard.
And you just come back to a massive API bill. But the system escalates early now. When it detects a stall pattern, it triggers a hard stop immediately, rather than allowing the AI to enter a death spiral.
That is a much-needed safety net.
To further ensure quality before a phase commits, they've also added new automated review commands, GSD code review and GSD audit fix.
So GSD code review performs a systematic analysis of the files changed during a phase, acting like an automated QA department looking over the AI's shoulder.
Exactly. And GSD audit fix can automatically resolve safe issues flagged by the review.
Oh, that's handy.
You can even configure it to run the full pipeline in one shot. These specific safety gates, the atomic locks, the stall detection, the automated auditing, are what finally make this tool reliable enough to leave unattended during a heavy phase transition.
Amazing. So what does this all mean for your workflow right now? Let's get to the bottom line.
Let's do it.
First, you need to update Claude Code to version 2.1.101 immediately. Purge those stale worktrees and stop the virtual scroller from hoarding your system memory.
Absolutely.
Second, update GSD to version 1.34.2 to get access to the new persistence layer.
And for the rest of the stack, Superpowers had no releases this week, holding steady at version 5.0.7.
Didn't know.
And if you are building in the .NET, C#, SQL Server, or Blazor ecosystems, there were no relevant updates in the marketplace. Your environment remains unchanged.
The most important takeaway, the immediate action item we want you to implement today, is initializing that global learning store in GSD.
Yes. Do not wait on this. Run the GSD tools intel init command in your terminal. Opt into the persistent.planning intel store.
It's so worth it.
The insights these tools gather are now cross-session, and the value of that intelligence compounds over time.
Huge advantage.
The developers who start building these persistent structural assets today will have a massive efficiency advantage over those who are still re-explaining their architecture to their AI every single morning a month from now.
The compounding nature of that intelligence is wild, which leaves me with one final thought for you to chew on.
Oh, I like this one.
If these tools are actively building a persistent, queryable, structural intelligence about our code bases, an intelligence that survives long after we close our laptops. What happens when the global learning store actually understands the intricate legacy logic of a massive code base better than the original developer who wrote it?
It's bound to happen eventually.
If your AI assistant suddenly maps the architecture more accurately than you do, will our primary job soon shift from actually writing the code to simply managing, curating, and occasionally correcting the AI's digital memories?
That is the big question.
It's something to think about the next time your AI reminds you of a routing rule you made up last year and completely forgot about. Thanks for joining us on this deep dive into the source material. We'll see you next time.